CoJack, a unique simulation program for safer, more economical and more transparent jackings. Nowadays, the new construction of supply and discharge lines in densely populated urban living space is only manageable by using trenchless technologies. Especially for larger cross-sections, usually pipe jacking is used. From a technical point of view, it's a challenging construction technique which demands a great deal of the engineers, especially when it comes to the structural dimensioning of the pipeline. When using this method, a jacking station starting from a starting shaft drives jacking pipes through the subsoil towards a target shaft. Here, the configuration and the application of machine technology decisively influence the strain of the jacking pipes. The main jacking station installed inside the starting shaft introduces the forces necessary for jacking into the pipe string. The jacking station is supported by an abutment inside the starting shaft. Especially over larger jacking stretches, intermediate jacking stations are used in addition. They segment the pipe string and thus limit the longitudinal forces acting on the jacking pipes. The annular space between the jacking pipe and the subsoil, which is specifically created by the overcut of the jacking machine, is filled with a support and lubrication fluid. It supports the subsoil and lubricates the pipe string, thus reducing the necessary jacking forces. A steerable shield machine added to the front of the first pipe enables the jacking. Depending on the geological and hydrogeological preconditions, it's equipped with corresponding excavation tools for removing the soil at the working face. In the following, the impacts on the jacking pipes during jacking will be explained. The green arrow symbolizes the face resistance, creating a constant longitudinal force inside the pipe string. The jacking resistance, here marked yellow, is far more important. It's caused by the skin friction between the pipe and the subsoil and generates a continuously growing longitudinal force. Inevitably, longitudinal forces have to be added due to scheduled curved jackings and unavoidable steering movements. Too frequent or too strong steering movements can lead to an enormous growth of the longitudinal force and to impermissible pipe strain. To limit the longitudinal force inside the pipe string to the permissible value, intermediate jacking stations are installed. They reduce the number of pipes that have to be pushed by each jacking station. The pipe joints do not only transmit the longitudinal force from pipe to pipe, they also serve as a joint to allow steering and flexibility in curves. For this purpose, pressure transfer rings are used. They're either made of softwood or chipboard and arranged between the pipe faces. Their task is to distribute the longitudinal forces as evenly as possible to the end face of the pipe in order to minimize the pipe strain. Here, however, the wood is loaded so heavily that it's not only subject to elastic deformation, but also to plastic and thus constant deformations. The pressure transfer ring becomes thinner. Due to the load changes and the steering movements during jacking, the pressure transfer ring steadily loses its load distributing effect. It hardens. This particularly influences the stress distribution in angular deflections of the pipe joints. So the force transmitting area decreases at the pipe ends and results in a gaping joint. The result is an increased pipe strain, in which the maximum stress occurs at the outside of the pipe. This is why, if overstrained, first damages in the form of cracks or even spalling occur exactly at this point. Usually, these damages cannot be noticed when accessing the pipe string. Conventional calculation methods do not include the hardening of the pressure transfer ring during jacking, so there's a constant risk of hidden pipe damages. The calculation program CoJack offers safe implementation planning, realization and supervision of the pipe jacking. CoJack considers the load history and with it the corresponding present state of the pressure transfer ring at any point in time of the jacking and in any pipe joint. The resulting nonlinear changes of geometry and stiffness are continuously included in the calculation. The three condition stages pictured here clarify the heavy influence of the constantly changing stresses on the pressure transfer ring's thickness and flexibility. Already in the planning stage, CoJack simulates the upcoming jacking measure by taking into account the planning requirements. In this way, it allows safe and economical dimensioning. After the start of the jacking, the planning data is bit by bit replaced by the measuring data recorded at the construction site. Special sensor technology acquires the jacking forces at the main jacking station and at the intermediate jacking stations. Precise precision encoders are installed at 3 points at selected pipe joints. They continuously measure the circumference of the joint gap in order to determine spatial deflections. For a plausibility check, steering movements of the jacking machine are registered in addition. All data is graphically processed at the construction site and is transmitted to CoJack. For the already covered jacking distance, CoJack provides the maximum pipe strain that has occurred so far and determines the safety level that's been achieved. For the remaining distance to be covered, a constantly improving prediction is set up based on the latest data. It refers to the pipe strains that are to be expected. For the first time, future risks can be noticed in time, for example, overstraining of a certain pipe as a result of a steering error at a certain point. In this case, CoJack offers various methods of resolution for preventing damage and checks their effectiveness. The so-determined optimal method of resolution, here the activation of an intermediate jacking station from a certain position onward, is instantly implemented on-site and in correspondence with the construction site. At the same time, it's recorded in CoJack. In this way, despite the problems that have occurred, the jacking can be continued without risk. Data can be exchanged via the World Wide Web or mobile telephone communication between the construction site and CoJack, so a structural supervision of the jacking measure is given continuously and independently from the location. CoJack is a comprehensive instrument that assures the quality of jacking measures. It supports planners, the jacking contractor and the constructor. For implementation planning, CoJack allows an optimal dimensioning of the pipes and a configuration of the jacking. During construction, CoJack prevents the development of damages and allows a flawless construction process. Regarding the construction approval, CoJack gives a reliable basis for assessing the stability and usability of the construction. CoJack, you can count on us.